Hey everyone. Welcome to another mock interview video, I guess. This one is on preorder string something validation something something. It's a pretty good problem. I encourage you to first do it and then watch this video, I guess. The thing is, I'm warning you that I didn't finish the problem. It had to do with a couple factors like C++ not having a split function, and sometimes the question just has a trick, and this time I didn't see the trick. I can keep giving excuses, but yeah, try out the problem first, then you can watch this video. It's very painful and there's a lot of dead silence with me just thinking. But if this was an actual interview, that would have been actually how I would have performed. Badly. But I still think the solution was actually pretty cool. So if you just want to skip all the mumbling and fumbling around, I'll leave a timestamp below so that you can skip to the part where I actually try to explain the solution, because it's pretty elegant, and there's a pattern and a lesson that you can get from it, so that in future problems it's definitely likely that you'll see a future problem that you can implement the same pattern or apply the same pattern as the solution. So yeah, without further ado, either keep watching or skip to the explanation of the solution. But you should definitely do the problem first. Alright, let's get started. Hey everyone, it is time for another mock interview. Let's just cut to the chase. Okay, so this is verifying preorder serialization of a binary tree. So one way to serialize a binary tree is to use preorder traversal. When we enter a non-null node, we record the node's value. If it is null, we record using a sentinel value such as hash. So the above binary tree can be serialized 934 hash 1 blah blah blah. Okay, and then given a string or comma, separate values verify whether it is a correct preorder traversal serialization of a binary tree. Find an algorithm without reconstructing the tree. Okay, so we're given a string and we're supposed to see if it's a valid preorder serialization. Given a string. Wait, but then so it's not asking if the serialization matches a tree. It's just asking if it's valid. Okay, I'm gonna read this again. For example, you can verify whether it is a correct preorder traversal serialization of a binary tree. So preorder is parent, then left, then right, and then parent, left, right. So parent, then 3 is another parent, 4 is another parent, then child of 4, then we go back to 3, and then 1 is a parent of 2 hashes. Okay, so then yeah, this is true, and then this is false because we need 2 hashes after the 1. And this is false because after 2 hashes you can't have another number, because yeah, like the parent is the 9, then you have a hash, then you have the left child's a hash, the right child's a hash, so they're both null, so there can't be another child. Okay, so they don't want us to reconstruct the tree. I'm wondering if we can just do one pass and just go through the whole tree. Yeah, let's try this out. So we take the first number, then we take the next number. If the next number is if it's a number, then the next number is the child of this number. Okay. I'm going to try to come up with some cases just so that I can like sort of develop a pattern, come up with a pattern. So let's just have numbers be 1 and then hash hash. So this is true, but then if there's 3 hashes in a row, it's false. If it's, let's see, so if it's a hash, number hash, and then another number, so that's the right node. And then yeah, so then at this point we don't really have to care about anything on the left side anymore, because this is just the right child, and then everything past this point is going to just be the children of this 3. So maybe it's just a matter of like having the right number of hashes and numbers after, if that makes sense. So okay, so I'm starting to get like a general idea, but I'm still going to try to come up with a concrete pattern. So 3 hashes in a row is a definite no. A number and then 2 hashes, and then anything, another number too, is also no. Now if it's a number, a hash, and a number, then it resets. Then anything can happen again. So after a number, it can be 2 hashes and 2 hashes and stop. Oh shoot, but then the thing is, okay, there's actually, what I said earlier is invalid, because if I have a number and 2 hashes, but there's like another number over here, then I could still have more over here, because this is the left child and this is the right child. So and you can't reconstruct the tree. So this is, again, I have to come up with the rules for taking the string or processing the string so that I can figure out if it's a valid preorder traversal. The idea of a stack comes to mind. Yeah, maybe I'll just use a stack. Yeah. Yeah, a stack is pretty good. Okay, and to explain why I think using a stack is good is because there are a lot of levels, and just having a stack sort of helps me keep track of every level, or like the next level, without worrying about 2 levels deep or 3 levels deep or whatever. Meaning if I had like a binary tree that was like a height of 20, yeah, I wouldn't have to care about like all the different nodes above the level I'm worrying about. Okay, so how would I use a stack though? So let's use this example. I would put in the 9, put in the 3, put in the 4, then when I reach the hash, I pop, so this is the stack, and 9 is the head. So when I have a hash, I pop, and then when there's a second hash, I pop the 4. Okay, well, how is having a stack different from just allocating the tree? Is there any way I can just do this just by looking at the string? I don't know. Yes, so the thing with the interview questions is like sometimes there are a lot of options you can consider, and I guess in this situation, when I don't really know which option is the best option, I can just think about each option really quickly. So right now I can go back to maybe try and figure out a pattern from just test cases, or I can keep trying to figure out how to use the stack. So I'm gonna go back and just quickly try to see if there's a way to just, whoa, to just process this, and then yeah, see if it works. So if I just process it one by one, yeah, I need to know how many levels are up there, you know, because 9, 3, 4, that's 3 levels in. So that's why the double hash marks still work. Whereas if it was just 4 hash and 1, the 2 hashes would cancel the 4, and then the 1 would make this false. So yeah, maybe I do need a stack. So now that I realize that I need a stack, how do I actually use it? So I put in the 9, I put in the 3, I put in the 4. The first hash mark doesn't do anything. Or it does? So put in the hash, and then the second hash would take out the 4. At the same time, if it's a 4 and a hash and then another number, then I have to complete this tree. You know, so what if this 5 also has like 2 hashes? This hash, okay, so the second hash would take care of the 5, and then taking care of this 5 would take care of the 4. And then at the very end, I just have to check if the hash, or if the stack is empty. I think that's a valid algorithm. I just have to figure out how to signal that I could pop off the stack. And even before that, I need to find out a way to parse the string. I don't know how to do that. Is there a tokenizer for C++? String.find. Okay. Okay, so that's what I have to do. Found +1. Okay. And it stops. Let's see. Wait, it searches the string for the first occurrence specified by the arguments. What happens if there's no, okay, if there are no matches, it returns. So this is what I'm proposing. While preorder dot find okay, and we're trying to find wait, I don't know if that's the one I'm looking for. I'm trying to split it. C++ string split by comma. Alright, I'm just going to copy this. Okay, so this code would okay. Okay. So this is basically my while loop that just goes to the next item, and wait, will this actually work? So you put the string in and then puts peak. Wait, this is only for numbers. I hope this doesn't happen in a real interview. Okay, this one seems better. How much time do I have left? All right, 20 minutes. I got this. Okay, so now the word or wherever is going to be in token. So I also need a stack, and it's going to be a stack containing a string and this. Is there std stack? There should be. Okay. So I have a stack. Now, just checking its methods. So there's push. So, and at the very end we return s.empty. Because if it's empty, then that means it's valid. If there's still something in there, then something messed up. Okay, so now we just process the tokens one by one. If token is equal to hash sign, do something else, we just have to push the token onto the stack. Now in the case that it is a hash mark, what do we do? Well, so if it's the first one, then we don't do anything. But if it's the second one, then we have to pop the first hash mark and also the number. Yeah. The hash mark we pop. Okay. So then the problem is how. First of all, there's a lot of edge cases going through my mind. Like, what if it's just 2 hash marks and that's it? What if there is no number at the beginning? How do we catch that? But even before that, so it's 2 hash. I'm also thinking, how do you chain stuff up? Because if you have 2 hash signs and you have 2 hash signs, you get rid of them and you get rid of the number above, that might be a right node, which also gets rid of the number above that and gets rid of the number above that, and so on. So how do you know whether you're on the left side or the right side? I could push a number. I could push it into a pair, so it's like a stack, which is a pair, and it's paired to the string, and then a character that says, or a flag that says left or right. And as long as it's a right node, then I would pop that one too. I'm just thinking, is there an easier way to do this? I don't know. I can't see an easier way at this moment, so I'm just going to let's say I'll pass in a character. So when I push, I'll be making a pair, a string char, and it's going to have a token, and so but then how would I know if it's the left side or the right side? Why is this problem so hard? I thought it was a medium. Dang. Okay, well, if I'm not able to solve this question, I'll definitely make an explanation video for it. Okay, so So right now I'm just thinking, like, is there, going back, like, is there a way to just derive some rules to just parse the string without having to use a stack? I guess first you can see that there's a correct number of items. Wait, no. So the number of items isn't. Yeah, it's not predictable because you can have paths that don't go all the way down if they're just cut off by a null. So what are the rules? The rules are that you go all the way left until you hit a hash, then you move up, then you go right, and then you go back all the way left until you hit a hash, then you go up, and then right, and then all the way left. So in this case, we go all the way left, we hit a hash, we go up, we go right, it's a hash. Then we get rid of that. Then we go right, and we go all the way left, we hit a hash, we go right, hit a hash. Okay, well, I think it's probably easy. It's probably easier to just use a hash. Use a stack. So going back, if we want to push this pair, we push the string in. We push the token in, but then how do we know if it's the left side or the right side? Yeah, so 9-3 and then 9-4. Well, I guess if you check the top of the stack, no. Oh, wait. You can check the top of the stack and then check to see if it's a left or right. If it's the top of the stack, Alright, so I'm the child. I look up and my parent is a left. Yeah, I really don't know. Well, if I start at 9, then I'm neither left or right, so I'm like a center. If I go to 3, how do I know it's a left? well, if my parent is a center, then I'm going to be, if my parent is center and the character before me is a hash, isn't a hash, so if the character before me is a center, then I know for sure I'm a left. And then if I'm another number and if the number behind me is a left, then I'm a left. Okay. But if, so let's say there's a hash and then there's a number. Oh, okay. So if the token before me is a hash, then I'm a right. If the token before me is another number, then I'm a left. And that is because, just every time there's a number, it's always going to be on the left side. But then after that, let's say there's like a lot of hashes. So these hashes will finish up that tree. So then we get another number. That number is going to be a right because if there's a hash before you, you know that a tree just got finished up, or a subtree just got finished up, and now I'm starting the right. So how much time do I have left? 5 minutes. Alright, time to sprint. So if the s dot top, if the top is equal to the hash sign, then I'm going to push, and I'm going to push saying that it's a right. Else s dot push pair string char, it's a left child. Okay, and then after knowing that, so if I reach a hash sign, the first one I just ignore. So if it's the one before me is a number, then I don't do anything. But if s.top isn't, or if it is equal to a hash, then I want to pop, and I want to keep popping until so while s.size, so while there is something to pop, and s.top dot second equal to R, so if it's a right then I want to pop is that it? I feel like I'm missing something. Okay, well, if my token is a hash and then the one before me is a hash, then I also want to pop the one that's before me. This does no error checking though. So what if there's 3 hashes? Well, if it's a hash, okay, well, what if there's a tree that just has a hash? Is that an empty tree or is that false? I don't know. That's something I should ask my interviewer. But for now, I'm going to say it's a hash and there's nothing left in the tree. So if s.size is equal to 0, return false. Okay, I have 4 seconds. I'm just going to submit it and see what happens. Oh man, feels bad. What's happening? Verify binaries. Hey everyone, so yesterday I finished this problem, not really, but I ran out of time and I wasn't sure if I should have just not posted this video because I just failed, or if I should just post it anyway. And I think I'm still going to post it because there's value in seeing me struggle, I guess, and I think the solution's actually pretty cool too. So the solution's right here, but first I want to evaluate my performance yesterday. I think that yesterday I was debating between seeing if there was a way to process the string in order to solve the equation, or if I actually had to use a stack. Using the stack had a lot of complexity, and I'm not sure if so me making the stack is basically sort of me allocating the whole tree again, so I'm not even sure if that approach was okay. And I think one thing that really got me stuck was that C++ doesn't really have a split function. Like, I think Java and Python have split functions where you're given a string and you're like split it by commas or split it by semicolons, and it'll automatically like return an array of that string, all the tokens split by that character you give it or whatever. So yeah, looking back, I spent a lot of time just getting that to work, and then in the end it didn't even compile because I needed to include something, I think, and I don't know if you can include stuff in Leetcode, but apart from that, yeah, I couldn't figure out a way to process a string in order to solve this question. And after looking at the solution, I'm like, oh, I mean, yeah, the solution's so obvious, but at the same time, I'm not really sure how I would have been able to arrive at this like on the spot. So this goes into how like you might not get all the questions immediately, but then if you look at solutions, now I'll remember the solution, and not just for the sake of, oh, if I see this problem again, I am like, oh, I know how to do this. It's more like there's a certain pattern, there's a certain theme that this solution has that other solutions in the future will also have. What was the question I did before? So the question I did before was the triangle question, and I feel like this solution kind of shares the same pattern as the solution for the triangle problem, but not really. Anyway, so let's get into the solution, and okay, so first of all, basically the gist of it is you start processing from left to right, and then every time you get a node, you add 2. Wait. No. Every time you add a node, you minus 1. So you have like a capacity, and then what is this? When adding a non-null node, it means, what the heck is a non-null node? Wait, I looked at this last night, so if it's not null, you add 2 because it's a parent, right? The goal at the end is to have 0 capacity, but when you add a parent, so something that isn't null, you add 2 to capacity, because if everything works out, later on when you see a null node, you subtract 1, and then you see another one, you subtract 1, because a parent has 2 children. I think if you look over here on the top, so let's say it's like 5 hash 15. At 5 the capacity would be 2, and then the hash would be minus 1, so now capacity is 1, and then at 15, or let's say it's a hash, then capacity would be 0, and you're good. Anytime that capacity goes to negative, then it's false, right? Because if you have another hash, then then that's not valid. Or if you have another number, that's also not valid, because I guess capacity is like how many seats you have left, and if you have no more room to have children, then you can't have any more, right? And if you have any more, then it's false. And so when, let's say instead of a hash you put 15, you still subtract by 1 because it fulfills the capacity given by 5. So it's like plus 2 minus 1 minus 1. But because of this 15, you have to add 2 again. So yeah. So I guess you can think of it like you're processing the string as if you're building the tree again, and you're just singling out whether or not it actually follows like the capacity, whether parent nodes have their children filled, and whether or not there are no extra nulls or not enough nulls. And yeah, so I guess we'll walk through the solution. So first you check if it's empty. If it's empty, you just return false, because I guess that's not valid. Then I guess this is like this line is to guard against the off by 1 error. Then they just loop through the whole string. So what I also did was I tried to tokenize the string, but you didn't really need to do that. All I needed to do was go to the last character before the comma, and then if it was a hash, then count that as a null. If it wasn't a hash, it doesn't matter if it's like a 3-digit number or a 1-digit number. I just care if it's a number or not. Yeah. So capacity is equal to 1 at first. Then they loop through the whole string, and we just keep going until we hit a comma. Afterwards, we hit a comma, regardless if it's null or a number. We subtract 1 from capacity because it fulfills the capacity from above. Then we check if capacity is less than 0, because if so, then this node doesn't fill in any isn't a children of any parent node from above, so return false. Otherwise, we look at the character from before, and if it's not null, that means it's a number, which means we need to find 2 more children below us, so we add 2 to capacity. And if all of this works out, in the end, capacity will now equal to 0. And we just check. If it's not equal to 0, then that means that this tree doesn't work. And yeah, that's the solution. So I think it's pretty simple. I think it's fairly elegant. My takeaway, I guess, from this is when I'm thinking about problems, this is sort of like an abstraction, and to be able to see this abstraction is okay. That might be like too broad, but I guess I could say this: like, from now on, I'll keep in mind that if I see a problem similar to this, I'll know to count. There's this, I guess you could say, there's this pattern where as you take in more elements, you have a counter, and if that counter ever goes below 0, then it's false or something. This can be like a validator. I know there's a similar problem dealing with you're given a string and it's like parentheses, and you're just trying to see if the parentheses are valid, like all the open parentheses match with the closed parentheses. I actually gave the solution to my friend a couple years ago, or like 1 or 2 years ago. He was like doing all the stack stuff, and I was like, why don't you just keep track of how many open parentheses there are? Like, you just count them, and then when you see a new open parentheses, you add 1, and then when you see a closed parentheses, you minus 1. And if at the end if at any point your number of open parentheses goes below 0 because you're closing too much, then you return false. And at the end, if your number is still positive, that means you didn't close all your open parentheses, so you also return false. And looking back at that problem, this problem is very, very similar. Instead of closing open parentheses, we're trying to fill out all the children of parent nodes. So yeah, hopefully that explanation made sense. Cool. So after this video, I think I'm gonna make do another mock interview video. Yeah, let me know if you guys like this video, like a video even though I didn't solve the question. Is it still valuable to you? This is another example of like how, even though I got so many internships, I'm not exactly the best at doing algorithms, and yeah, like I already said this before, but on the job you're not really required to come up with this. It's either this one is like either you see the trick or you don't. It's kind of a trick, right? To be able to know oh, I should count the capacity or whatever. Yeah, so yeah, just let me know, and hopefully I'll see you in the next video. Thanks.